Okay, today we're going to work through 6 integrals to test our integration knowledge. So I'm going to start with the first one here, the integral of sec squared. Now the integral of sec squared is a bog standard result, and we know from the formula booklet that that's just going to give us tan of x plus our constant of c, and we should state that c is a member of the real numbers, because when we're stating a letter we should state what this is. So that's the first one. Let's look at the second one, shall we? So the next one, if we move along here, is 3x plus 2 to the power of 5. Now, 3x plus 2 to the power of 5, we can also use a standard result on it, because if we remember, if we were going to differentiate something like 3x plus 2 to a bracket, in this case, if I put it up to a power of 6 and I differentiate that by the chain rule, that's 6 times 3 of 3x plus 2 to the 5, which is 18 lots of 3x plus 2 to the 5. Now, I've got 18 times too many of what I want, so to get rid of that, all I need to do is do 1 over 18 lots of 3x plus 2 to the 6, and have my constant of integration to ensure that those 18s will cancel each other out once you go back and differentiate this thing here. And I will just show you, if you do indeed want to go ahead and differentiate that in respect to x, we can do that very quickly. That's 6 over 18 times 3, also 3x plus 2 to the 5, and of course this is 18 over 18, also 3x plus 2 to the 5, which is 1 lot of 3x plus 2 to the 5, which is precisely what I started off with in my integral in my question. So just to show you that method does actually work. Okay, this is in effect the reverse of the chain rule, in effect, but we call it a standard result in an Excel. Okay, so we've got x root 1 plus x squared next. Now this one is definitely a reverse of the chain rule, because we know that the root of something is just x times 1 plus x squared to the half, in respect to x. Now this, if we add 1 to the new power, we'd get 3 halves. So then if you differentiate that by the chain rule, you've got 3 halves coming out the front, and then you've got a 2x, lots of 1 plus x squared to the half. These 2's will end up cancelling each other out here, so we're going to end up with 3x of 1 plus x squared to the half. But I don't want 3x, I just want x. So the way to get rid of that is to divide by the 3, i.e. multiplying by a third. So my final integral will come out as 1/3 of 1 plus x squared to the 3 halves, plus some constant c, and I should state that c is a member of the reals. I forgot to do that on the last one, I apologise. And again, you can test this if you like. So we've got 1/3 of 1 plus x squared to the 3 halves. We can differentiate that 1/3 times 3 halves times 2x of 1 plus x squared to the half, like 1 and the third will cancel, the half and the 2 will cancel, so that's just going to leave you with x, 1 plus x squared to the half. Precisely what we started off with. Okay. So we've got 3 more for us. We've got this one here. We've got the integral of 4 sin x cos x over 4 minus 8 sin squared x. Now the trick here is that this is just a set of standard results, and we've got the formula booklet on the right hand side, because I think we might be needing that. So 4 sin x cos x, well, we know that sine of 2x is 2 sin x cos x. So 4 will be just 2 sin x 2x on the right, on the top end of our integrand there. On the bottom, we can factor out a 4 if we like, of 1 minus 2 sine squared x. You might be wondering why on earth I would do that. But because I know that cos squared x minus sine squared x is the same as cosine of 2x. Now if I replace this with 1 minus sine squared minus sine squared x is cos 2x, then I get 1 minus 2 sine squared x is cosine of 2x. So that's the formula I want to use. So we've got the integral now of 2 sine 2x over 4 cosine 2x. So I've got a 2 and a 4 will cancel down to a half. And I've got sine 2x over cos 2x. Now that will be tan of 2x, where identity for tan of x is sine x over cosine x. So we've got half tan 2x, yeah, to find. And if we go back to the formula booklet, we want this one here. And we're going to use that to integrate. So we're just going to get 1/2 times a half of the natural logarithm of sec 2x. Make sure you include those modular signs, they're quite important. And again, plus some constant c of integration, where c is, remember, the real numbers. Because c can just be any constant real number that you like. And really, I should multiply that out a little bit and say it's just 1/4 of the natural log of sec 2x plus c. If I was being really picky, but I've already stated c is a member of the real, so I don't need to state it again. Okay. So that's how you do that one. Okay, next one, make sure you have a go at these before I go through the solution as well. So we've got 2x sine of 3x minus 1. Now, I've purposely picked these all different, so we're not using the same formulas all the time. Now, here we've got a function of u and a function of v. Hence, this one I want to use by parts. Now, you might not remember the by parts formula. To be honest, I don't either. So instead, I use the DI method. I'm going to show you this method. Now, AQA at Excel LCR will say that if you show you're working but you make an error in it, then you lose all the marks. However, if you do it correctly, you can gain all the marks. So you just got to remember the order that you do these. So sine 3x minus 1 is going to be my integrating column. The D for differentiating, so I'm going to differentiate 2x to get 2. Integral of sine of 3x minus 1. Well, if we know that way, we can just factor the third out, and we know the integral of sine x will go to minus cos x, so it's going to be minus a third cosine of 3x minus 1. That's a plus, that's a minus, because you remember plus minus plus, and then we can just stick this straight in here. So we've got minus 2/3 x cosine of 3x minus 1 plus the integral, because we've got a minus minus, don't forget, plus 2/3 cosine of 3x take away 1. That last line will always be the final integral that you add on the end. And then again, we can tidy this up. And now this is just a straightforward integral. Integral of cos is sine. Just remember to divide by the 3 here, so it's going to be 2/9. And cos goes to sine 3x minus 1 in the integration, plus some constant c, where c is just a real number. Okay. Now, if you wanted to do it using the formula, I do remember the formula now. The integral of u of v prime, that u, is u times by v minus the integral of v du by dx. Now, if you would go do this in the same way, your u would be 2x, your v prime would be sine of 3x minus 1. Then you could integrate to get your v, which would be the minus a third cos 3x minus 1. You could differentiate that to get 2, and then you could do that times that minus v times by du by dx. And again, you can see you get the exact same thing that we did by using this little table. That's called tabular integration, the DI method. I don't mind either way. I do think, though, that this one is a little bit easier to remember. Then again, that's just personal preference. Okay, so we've done one by parts. Let's look at the last one here. This one is just a bit of a trick, where what we're going to do is to split that numerator up. The technique is called splitting the numerator. Now, we've got to be slightly careful. If the integral was like this, for example, then you could not do this technique. It's top heavy. We've got we've got 2 terms over 1 term, that you'll have to split. When you've got 1 term over 2 terms, you cannot split that. And I'd be thinking maybe you want to go down partial fractions, or maybe you want to do some long division. That's where I go with that one. I'd try it, just give it a go. But just to show you, you could not write that, so this is something I wouldn't do. It's not the same as root x over x, and then it'd be minus root x, wouldn't it? It's not the same as that. That's rubbish. You cannot split that, but this you definitely can split as just the integral of x over root x minus 1 over root x, because we can integrate each of those very, very, very easily. Now, really, if we got 2 terms, we should put a bracket around it. We don't need to, but if you want to, you can do. Now, we've got x to the 1 divided by x to the half. Now, 1 minus a half using index laws will just get you the integral of x to the half. And minus 1 over root x is x to the minus a half. Just got to be slightly careful with your minus signs there. Okay. So what we need to do is just integrate that term by term. So x to the half will be just 2/3 x to the 3 halves. That should be straightforward. And this minus x to the minus a half here would be minus 2x to the half. Well, we're putting a dx there, and a plus constant there, and a c being a member of the reals. Good. So I hope that those 6 little integrals there are actually quite helpful for you. Just to practice your integration skills, I will give you a forewarning that those are quite straightforward. If you want more of these integrals, I will happily do some more videos on these, just to practice your integration skills. If you want a differentiation one, I'll happily do that for you as well. Okay, so that's going to be the end of this video, and I will see you in the next one. Bye-bye for now.